Yeah, today we are just going to look at a short intro on functional Java, and we're going to discuss it like we are novice, like we don't know anything about it. So for starters, we have to import the Java util.function package, because it is within this package that the different functional interfaces lie. And you can look into this package and you see all the different interfaces or Java functional interfaces, and you can have a look at any of them. Since yeah, we could look at one of these, and then we see that this is an interface that has two generic types, T and R, and then it has just one method, and that is why it's called a functional interface. It has just one method, and that particular method or contract is an apply method that is going to take a type T and then is going to return the type R. So this is an input type, and then this is a result type. So this is just a function. All other interfaces are defined in similar fashion. You could see some of them taking a particular type, either 2 or 3 or 4 of those types, and return another type. But yeah, this is basically what you're going to see. So the Java functional interfaces deals more with generics. It takes a certain type and some other types are going to return. But yeah, let's go back to our class and then we'll see yeah, it's in practice. So before we continue, I would like you to keep in mind that by, anywhere you hear by implies two, and then anywhere you hear unary, it implies one. Now, for the purpose of this explanation, I've grouped the Java functional interfaces in four. There is the functions. I don't know why. the name sometimes confuses. And then there are the consumers, there are suppliers, there are predicates, and then there are what? Operators. I'm going to go over each of them one after the other. So we'll start by defining what a function is, what a consumer is, and all that. So we'll start by defining what a function is. A function, for simple terms, is just a method, like the regular method, that takes a certain argument, because your method takes arguments, and then returns a result of a certain type. So that is simply a function. We could define a simple string method here. We could say, okay, this is a method that is going to do toString by taking an integer I, and then we write our implementation here. This is a method in Java, but similarly, this also is what we actually call a function, because it takes a type I, which is an integer, and then is in the end is going to produce a result, which is a string. However, functions give us the capability to define methods that are assignable to variable. So for instance, you've defined this method, but you can't really assign this method to a variable. You can't pass this method as an argument into another method. You can't say, for instance, this is a method. No, you can't do this. Okay, you can't define this method and then assign it to a variable m. But with functions, we can do that. You can't also pass this method into another method as an argument. Say, for instance, you want something like this. I want to, okay, return a string, but I want to take this my method and then pass it inside here as an argument. That is not possible. But with the Java function, you get two things. You're able to assign it to variables, and then you are able to pass them as parameters to other methods or other functions. Now, away from that, what does a function interface or looks like? A function, by definition, is an interface that is going to take an input of type T and is going to return you a result of type R. It takes T input, return you type R. So like we've defined, string, return type, int, arguments. So we could do that and just say this is going to be string, an integer, and then we are going to call this function from string to int. Oops. Okay, I turn this around. Let's make it function from integer to string. int to string. And then there are several ways you can define this. One of the ways is by instantiating this particular interface as an anonymous class. By instantiating, you could call it anything. Implementing this interface. This is an interface, and you implement interface. So you could provide a concrete class for this, and you could do that by saying, okay, this is going to be a new function. Immediately you type this, IntelliJ helps you, and then you say it's going to be a new function that is going to take an integer and return a string. And then within the apply method, which is overriding, you get to see that integer is the argument and then string is the return type, and then you provide your implementation here, and that implementation could be something as small as string.value of integer. This is fine, excellent. You could go the route of lambda functions. Lambda functions are functions you write for methods, for interfaces that have just one method. For instance, this is an interface and it has just one method, so we can go the route of lambda function. We can just do this by control clicking, hints, and then we switch it that way. Or we could our own self say, okay, I want to define this function as something that is going to be, whenever you give me an integer, I'm going to call string dot value of, and then pass the integer. But for simple cases like this, you can even go a step further, and then you use method reference, and going to say that, okay, whenever an integer comes, since I want to call string the value of, I can just simply say I want to do string dot value of. Great, value of. Great. So this is the same thing. Now, like I've told you before, we can't assign a method to a variable, but in this case, we've just created a variable, and this is the variable name, and this is the implementation to that variable. So we've invariably assigned a method to a variable, and then we can call this, and the apply method is going to apply the input for us. Now that is functions. The next one is consumers. Think of a consumer as something that consumes. It takes something inside of it. It doesn't produce anything. It's a function that takes an input but produces nothing. It swallows things inside of it. So that's what a consumer is. You check the consumer interface just by typing it out. You see that the consumer interface just takes a T, so it takes a type, and then it produces nothing. So it takes an input, say for instance a string, and then it's going to produce nothing, meaning it's just going to do like a side effect. So consume string is just going to say, for instance, print to the console south. It's just going to print to the console and nothing else. So it just takes stuff and then it doesn't return anything. Now supplier, think of a supplier as an interface that produces a value out of nothing. It's able to produce you a value. It doesn't need an argument. It doesn't need anything. It can produce you a value. And that's what a supplier is. So if you type a supplier, you see that a supplier is also typed with one generic type, which is T, and then it's going to say that this is going to be a supplier of a string, meaning out of nothing I'm going to create a string. So supply string, and then this is just going to be defined this way. Well, I could go the route of saying new supplier, and then we implement the get method, or we can actually provide more like a runnable, and then we're just going to say provide me hey, nothing else. So now this is how you define a supplier. Now a predicate is an interface that takes an argument and returns you a boolean. Yeah, that's all it does. It returns you a boolean. So we use it to like test, in cases where you do if else statements. Predicates are good in those places because they test stuff. So it takes a particular argument and then it runs a test on that argument and returns you a boolean, because after you run a test on any stuff, it's either the test succeeds or the test fails, so it's kind of checks. So that's a predicate. And then you see when you write the predicate, and the suggestion that your IntelliJ pops up is that a predicate takes a type T. So predicates can take something like a string, so meaning I want to test a string, so I'm going to say predicate, and then what am I going to define it as? I'm going to say whenever I have, or whenever you give me a string, I'm going to do if that string is not empty. Okay, for simplicity, if that string is not null. So this is a predicate, and then of course you can turn this into a method reference or whatever you like. But one good thing you could look at when you check the predicate interface is that it has just this test method. So that's all you have, and we can liken these predicates to be like a function that takes a T and then returns a boolean. So if you, for instance, you can define, say, a function that takes a string and returns a boolean to be predicates 2, and then you have to now say, okay, when it takes a string, what am I going to do? So if you give me a string, I'm just going to check that the string is not null. And then when you do this, these two functions are exactly the same thing. In fact, IntelliJ would suggest to you that, oh, you could switch this to be a predicate of a string. And then by doing that, of course, you can switch with the hints to make it a predicate of a string. Yeah. So these are functions, these are consumers, these are suppliers, and then these are predicates. And then what are operators? Operators are simply extensions of functions. They give you ways in which, yeah, you could play with functions basically. So they are just an extension of a function. So there is the unary operator, which says that it is a specific kind of function. A unary operator is a specific kind of function that will take a certain type, say a string, and then the result is going to also return is a string. So I'll take a string and I'll return a string. And then if you check the implementation of this, you see that a unary operator is just a function that takes a type and return that same type. So it doesn't do anything fancy. So I'm going to take a string and I'm going to return a string. And then there are other types. I'm going to comment this because of time. There are other types like the binary operator. So binary operator is saying I'll take 2 times this type and I'm going to return that same type, meaning I'm going to take a string and I'm going to return a string. So it's like defining a method. If you look up here, it's like saying private string M, which is just a method that is going to take a string K and another string W, and then yeah, this is just a method, right? So I'll take this string, I'll take this string, and I'm going to return a string. Great. So that is what a binary operator is. Like I said, binary is 2. I'm taking 2 of the same type. And if you look at this interface, you see it implements by function, and a by function is a function that takes 2 input types and is going to return a result type. So you can look into a by function. Is going to take type T, type U, and is going to return this type as the result. So yeah, basically all this forms the basis of Java functional interface. Although I've not pointed out like where you use them, but these are things you see every day. You see them in like your streams API maps, you see them like a completable future API supply, .then supply or .then apply and stuff like that. You see them everywhere. And then I believe that with time you are going to touch all these, and then we are going to talk about all of them. It is quite interesting. And then I can show you how you can move from writing things as simple as this to writing things that are as complicated as this. Yeah, where you define just using functional interface stuff like this, or you could even define stuff like, if you give me a sec, update one. Yeah, you could define stuff like this, where your method takes things like this, and you could define even complicated types like this, and then you see how they actually play in together. But anyways, like I pointed out, this is just a short intro to tell you about functions, consumers, suppliers, predicates, and operator. Now, to answer questions of like, what does this annotation mean? Well, this is just a marker annotation. When you put it on a particular interface, it makes the compiler check that that particular interface has only one method that is unimplemented. So if you go to like consumer, this is just telling the compiler, hey, this guy has marked this interface to be functional, so only one method must be unimplemented. If there are multiple methods that are unimplemented, then the compiler is going to complain. It doesn't do anything. It just marks that particular class. Then you've seen things like what are pure functions. Well, pure functions are basically functions that, given the same inputs, would yield the same outputs. Nothing changes. Same inputs, same outputs. And all these are pure functions basically. If you give this particular function, for instance, number 1 as an integer, is always going to give you string.value of 1. It's never going to change. If you give this function like string Chris, is always going to print out Chris. Nothing would change. So all these are pure functions. The third question you see here is, how was this design in Java compared to like stuff in Scala? Like I've said, Java went with the style of designing these as this. By these I mean like the functional classes or functional interfaces as interfaces. But in languages like Scala, they are defined as classes, and then those classes have one method that is called the apply method, and that apply method basically is how it does its stuff. And it's quite simple. We could even define it in Scala. You have something like class function 1, which is a class. It would have private, final. Okay, function 1 is of course typed of type T. So going to take primary, final, T, arguments, and let's say this is a function from T to R, so argument, and then we are going to put this in the constructor arg, and then Scala has this method called apply. Well, I'm going to call this an abstract class, and then we have what we call the R apply that takes nothing basically. Otherwise, abstract, great, abstract are this. Yeah, this is wrong. Basically, this is taken as the argument. So this is how it's more like defined in Scala. They are defined as classes, as opposed to Java that went with the route of defining them as interfaces. Now there are different advantages for doing it in this style, and then there are also advantages in doing it in the Scala style, because like you've seen within here, I can declare different fields and then use those fields to manipulate what happens inside of the abstract class, or sorry, the abstract method. Away from that, the next question is, when will I use these? It seems too vague and you probably don't need them in your job. Well, you use them every day basically. You see them everywhere, you've touched them, you play with them. It's more, the more you become aware of them, the more you know how to play with these and write even better functions and things that are simple, straight to understand, and yeah, are able to use them like a pro basically. So yeah, this is it. I hope it's informative. Over time, when we touch each of them and then we play with them, yeah, you get better insight. All right, thank you and take care. I appreciate listening. Bye.